Well, now we're doing the worksheet problems for Unit 3B. So the first one says, and does this make sense? Last year my heart beat 4 times 10 to the 7th times. Well, let's do a little dimensional analysis and see if we can come to a conclusion. So, say a person has 60 heartbeats per minute. 60 beats. And there are 60 minutes per hour, and we have 24 hours per day, and 365 days per year. So the minutes divide out, the hours divide out, the days divide out, and we get units of heartbeats per year. And so this is 60 times 60 times 24 times 365 beats per year. Now let's, next step, let's liberally round. So I'm going to say that's round these 60s up. As a matter of fact, 60 times 60 is 3,600. I'm going to round that up to 4,000. And I'm going to round 24 down to 20. And round 365 up to 400. So that's beats per year. And so this equals, let's see, 32, and we've got 32 million. Now we're going to round this up to 40 million, which is 4 equals 4 times 10 to the 7th beats per year. And so yes, it does make sense. If we a person could have 4 times 10 to the 7th heartbeats in a year. Next, and that was 1. So now let's do 2. The number in an ordinary, write the number in ordinary notation. Okay. So this is 2, and we've got 8.8915 times 10 to the 5th. And this can be found, by the way, this information can be found on page 145, and that's how to work with scientific notation. And let's see. So this is going to equal, now this says move that decimal place over 5 times to the right. So 0, moving it 1, 2, 3, 4, and we'll need a 0 here to move it 5 places to the right. And there's our number. And what is that? That is, C, yes. I'll put it. Okay, for number 3, another scientific notation problem. And it says, so divide these. Use scientific notation to perform the following operation. Leave your answer in scientific notation. Okay, so we have 4 times 10 to the 4th divided by 2 times 10 to the negative 1. And this is all multiplication, so 2 goes into 4 twice. And so now we have 2 times 10 to the 4th times 10. And if I change the sign on that exponent, then I have to move that base up into the opposite position, which is the numerator. Well, that's 10 to the 1st. Well, the 1's understood, so that equals 2 times, and now we add exponents. The understood exponent here is 1 because we have like bases, so 4 plus 1 is 5. And we're done. And what letter is that? Do we have that? Yes, that's A. So for number 4, determine by what factor the numbers differ. In other words, how many times larger is the first number than the second? So we'll just divide. We've got 10 to the 48 divided by 10 to the 16, and that equals 10 to the 48 times 10 to the negative 16. If we change the location of this base in the denominator, then we have to change the sign on the exponent. Now we have identical bases, so we can add the exponents, and that's going to be 10 to the 48 minus 16, which is 10 to the 32, and that corresponds to answer D. Okay, let's get number 5. And 5, same situation. Now our numbers are, so this is 5, 10 to the 12th, and we're going to divide by 10 to the 36th, and so that equals 10 to the 12th times 10 to the negative 36. We move the position of 10 to the 36 up into the numerator, and so we have to change the sign on the exponent. Now the bases are identical, so we can go ahead and add the exponents, and that equals 10 to the negative 24th. And again, that's D. Now for 6, we have 5, excuse me, 5.6 times 10 to the 8th, and we're going to divide by 1.4 times 10 to the negative 4, and now 1.4 goes into 5.6 4 times. So now we have 4 times 10 to the 8th, and we can move this factor upstairs if we change the sign on the exponent and make it a positive 4. So that's 4 times 10. Since we have identical bases, we can go ahead and add the exponents, and that's 4 times 10 to the 12th, and that corresponds to A. Let's stop, and we'll do a part